Hello class. In this video we're going to be reviewing how to compare ratios. Now before we actually start taking notes, I do want to remind you, if you are someone who needs to hand in your retake slip, please do so. I'm going to leave the blue bin on my desk, so if you want you can just stop by and drop off your retake slip. Be sure to take detailed notes when you are completing this video. I will be checking your notes when I do return tomorrow, so make sure that your notes are detailed enough. Anything that is on the screen, other than the directions I'm giving you right now, should be in your notebook. And lastly, once you are done with these notes, please continue working on the worksheet that I gave you yesterday. There will be some extra slips on the board in the clip if you do need an extra slip for whatever reason. Now, in our first example, we're going to be comparing three mixes of iced tea. So mix A, B, and C all have a different amount of cups of water and a different amount of cups of flavor. And the way we're going to tackle this problem is I want to make sure that these ratios that we have, in this case 2 to 7, 1 to 5, and 5 to 14, all share a common value, either the cups of water or the cups of flavor. Now for this first example, we're going to be comparing the cups of water. So I'm going to need to find a common multiple between 7, 5, and 14. So I do know that a common multiple between 7 and 5 is 35, and finding a common multiple for 7, 5, and 14 at the same time can be difficult, but we do know that 7 and 5 share a common multiple of 35, and a common multiple between 35 and 14 is 70. So I know that each one of my ratios should have a value of 70 for the cups of water. And what we'll be doing now is finding the scale factors between the original cups of water and the 70 cups of water in order to figure out how many cups of flavor we use to make those mixes. Now, I know from 7 to 70, that's a scale factor of 10, so I have 20 cups of water. From 5 to 70, I know that's a scale factor of 24. So I will have 1 times 24, which is just 24. So we have 24 cups of flavor in this example. And lastly, 14 times 5 gives me the scale factor between 14 and 70. So I do know I'm going to be multiplying 5 by 5, which is 25. Now I can see from this example that mix C is going to be my best bet for a more flavorful mix, because while all of these mixes have the same amount of water, mix C just barely has more cups of flavor than mix B. Now you don't always have to make sure that you have the same amount of water. You could actually compare these ratios by making sure you have the same amount of flavor. So just like last time, I'm going to be writing my ratios: 2 to 7, 1 to 5, and 5 to 14. Now, if you noticed in our last example, this common multiple was a little bit difficult to find. While I already had this work completed before I started this video, some ratios are a little bit easier to find common multiples for. For example, if we look at the cups of flavor, we have values of 2, 1, and 5. And you should be able to see that a common multiple between 2 and 1 is 2, and a common multiple between 2 and 5 is 10, which is a lot easier to work with. So we're going to make sure that each one of these recipes includes 10 cups of flavor. And these scale factors will actually be a lot easier to find. So from 2 to 10, it's a factor of 5. So that means we're going to have 35 cups of water. From 1 to 10, it's a scale factor of 10. So this means we are going to have 50 cups of water. And from 5 to 10, we are going to have a scale factor of 2. So in this example, we will have 28 cups of water, since we are multiplying 14 by that same scale factor. Now, just like last time, we're going to see that mix C is still the most flavorful because our ratios didn't change. Now in this example, we have the same amount of flavor for each of these mixes, but mix C has less cups of water, meaning that the flavor is less watered down. Now there is a third way you can compare these ratios. And for this example, we're going to be ignoring mix C because we already know that mix C is the most flavorful. So we're only going to be comparing mix A and mix B. And in this example, what we'll be doing is just comparing the fractions of the cups of flavor within the mix. Now, what I mean by that is I know that this mix A has 2 cups of flavor out of a total 9 cups of ingredients. Because with the 2 cups of flavor and the 7 cups of water in the pitcher or whatever we're using to mix the iced tea, there's going to be 9 total cups of ingredients. Now for mix B, similarly, we have 1 cup of flavor, but in total we have 6 cups of ingredients. So now I just need to compare 2/9 and 1/6. So I'm going to find a common multiple for my denominator, or in this case, a common multiple for our total amount of ingredients inside of our pitcher. So I do know that a common multiple between 9 and 6 is 54. And if I multiply 9 by 6, I'll get my common denominator of 54. And if I multiply 6 by 9, I'm still going to get that common multiple of 54. So I'm going to rewrite my ratios here after I apply my scale factor of 6. So I'm going to have 12 54ths, and I'm going to be comparing that to 9 54ths. So here in our new recipe, we have 54 cups of ingredients. 12 of those will be cups of flavor. And in this recipe, we still have the 54 cups of ingredients, but we only have 9 cups of flavor. So I know that in this specific example, mix A compared to just mix B will be the most flavorful mix of iced tea. Now that you're done taking notes for the video, I do want to remind you to please finish the worksheet from yesterday. If you do finish the worksheet early, be sure to put it in your binder. And from there, you're going to be working on IXL J1, 2, 3, and 6. Now, if you are someone who still needs to retake an assessment, what you can do is log on to Power Learning and make sure that you complete a retake video. The sub knows that you either have an option of completing the retake video or completing these IXLs. If you have any questions, please feel free to message me on Power Learning. I still will be in the building today.